Okay, are you ready? Do you think we can do this a bit faster? First, let's factorize. That'll give us the roots. Okay, so I take out a common factor of, good. That leaves you with x minus 4. Okay, so now I can, actually before I can differentiate, you can see I've got roots here, right? Namely at 0 and at 4. Also, you're sort of anticipating a feature here because that x cubed will give you not a single root or a double root, but a triple root, right? We could actually already know those are horizontal points of inflection. Okay, so let's just look out for that as we keep going through. First derivative gives you 4x cubed minus 12x squared. Okay, so factorize. What can I take out? 4x squared. And that leaves you with x minus 3. Okay, so that gives me stationary points at x equals 0 and 3. Okay, last bit, second derivative. This turns into 12x squared, and this turns into 24x. Okay, so I can take 12x out of that, which gives me x minus 2. Okay, so now I have possible points of inflection, and I've got two of them, namely at 0 and 2. Okay, so let's draw this guy. Okay. Now, this is a quartic, okay? So just like with your cubic, the leading coefficient tells you generally what kind of shape you're going to have, okay? So because it's positive, I'm expecting this kind of thing, okay? So I'll keep that in mind as I draw. I've got roots at 0 and 4. 0 and 1, 2, 3, 4. Okay, again, be careful for your scale because they're going to come in for us later, okay? I've got a stationary point and I've got this possible point of inflection at 0. And again, you can verify, but we sort of already know you're going to get a horizontal point of inflection at the origin. Okay? Now since I'm coming down, I'm going to label that here. Okay, again to double check. If your part A, right, or your part 1 was, prove that there is a horizontal point of inflection at the origin. Okay? This wouldn't be quite enough, would it? Okay, we'd actually have to test the concavity on either side to show, yeah, it's concave up, and then it's going to be concave down in a second. Okay. Okay. What other features have we got on here? We've got the stationary point, which is a horizontal point of inflection, already accounted for that. At 3, I'm expecting another stationary point, and I don't know where, like up, down. So I'm going to put my 3 back in here. 3 to the 4 is 81 minus 4 lots of 27, which is 108. So 81 minus 108 is minus 27. Yeah? That looks right, yeah? So I'm way down here, okay? So because I haven't put anything else on, I'm just going to say 3 here. I'm going to call that 3 minus 27. Okay? And I'll just have to watch for later on for where my other points will be. This is going to be a stationary point. Okay? I'm expecting it to be a minimum. Okay, because this is the shape that I'm getting. Okay. Okay, let's keep going. I've got my 2 stationary points in place, and now I've got this horizontal point of inflection, check. Another point of inflection at 2. 2 what? So when x is equal to 2, y is, sorry, this is my first one. I'm going to get 2 to the power of 4 is 16 minus 4 lots of 8, which is 32. So this is minus 16. Okay. So minus 16, what's that? It's past halfway, isn't it? So if I've got minus 2 here, I'm thinking something like that. Okay. That's going to be 2 minus 16 point of inflection. Okay. Do we have enough in our heads? So we're coming down here. We hit this horizontal point of inflection and bend. Okay. Then you're coming down, you hit another point of inflection, bend, here's our turning point, and then you come back up, and I've got to hit through 4. Okay, So, you ready? Should we try it? Okay, there's one part. Now here I've got to make sure this was concave up, so I'm changing concavity here. So this is concave down, right? I change again to, oh, here we go. I'm going to have to be steeper. Didn't do it very well. There we go. And up. That's bad. There we go. Yeah, it's close enough. So you can see what I've done, just to make it really clear, right, is I've made the points, the critical points, super obvious. So I've got like big fat dots there, so you can see that's the point of inflection I'm talking about, that's the minimum, and so on. Okay? And yes, I should label. So that's how finding the critical points and then plotting them on a graph, that's how it plays out, and this is the kind of detail that you'd be expected to replicate. Okay? Does anyone need